In MCQ 17, we shift our focus to speed of reaction. So in this case here, we have 0.5 grams of magnesium ribbon and 1 mole per DMQ of hydrochloric acid. A critical term here to use is the word excess. So a reactant that is actually being identified as excess, it has only the ability to affect the speed of reaction, and this itself will be manifested in the gradient of the curve. Alright, however, they do not have the ability to affect the yield of the reaction, which is manifested in the height of the graph itself. So that would then make my magnesium ribbon here to be limiting. So by it being limiting, it can affect the speed of reaction through the gradient itself, and also its mole. The mole of the limiting reagent can affect the yield of the reaction, and this is again manifested in the height. So since magnesium itself is considered to be a solid, one of the main ways that it can affect the speed of reaction that is special and unique to a solid is going to be with regards to the exposed surface area. You can look at things like powder and pulverized. And hydrochloric acid here is considered to be a solution. So something unique to solution is going to be its inert concentration. So high concentration will have a higher frequency of effective collision. But as a general items here, that is regardless of state symbol, catalyst could have come in here to speed up the reaction. So the curve does become steeper, but the yield remains to be the same. Or we can also manipulate temperature. And temperature comes off with the general understanding that for every 10 degrees Celsius, we should be doubling the rate of the reaction. Alright, again, this is just a little bit of a diversion of what the question actually wanted. So this, I will always advise to write an equation here first. Magnesium ribbon plus hydrochloric acid. This will provide for us magnesium chloride as our salt, which is aqueous, and the liberation of hydrogen gas, which is what the question was actually tracking in the graph itself. So we're going to repeat this experiment, this time around maintaining the use of 0.5 grams of magnesium ribbon. So that means that the height of the graph must be the same. Height of the graph must be the same because I did not increase the mole of my magnesium. But I'm going to double up the concentration of my hydrochloric acid to 2 moles per DMQ. So while the height is going to be the same, it should be steeper. So let's talk about the height portion here first. B as well as D are good contender because both of them terminate at the same height of graph 1. But in terms of steepness, because of the greater concentration, you should be looking at the general steepness of graph 1 is over here. You should be looking for something that is steeper. Then that itself will actually be seen in graph B. It is steeper, it took a lesser amount of time to reach the maximum amount of products that can be formed. So B is the answer that I am looking for.